In this video, we're going to learn about networking and communication. This is chapter 5 of our book. These are our learning objectives. Basically, we're going to learn about networks in general and specifically about the internet and how the internet works. So let's begin by discussing a brief history of the internet, how the internet came to be. Well, often necessity is the mother of invention, and that's what happened with the internet. The military needed a way to have computers communicate with each other, and this was during the Cold War when fears were very high, particularly from the Soviet Union. So the military wanted to be able to connect computers and allow them to share information. So in 1968, that's when proposals were put out for computers to communicate with each other. In 1969, the project was completed, and that involved different learning institutions. That's the second part of the internet. First was military, and then it was learning institutions. So then came along businesses and the dot-com boom. Initially, businesses had their own client server networks within the business, but if we wanted an internet to be able to exist, we had to have a way for these internal company internets or networks to communicate with each other. And to do so, we needed a standard language called a protocol. And a protocol is just simply a standard way of communicating such that we can actually have the internet work. So the internet is just an interconnection network of networks. So I want you to learn TCP/IP. That's the language of the internet. Very important standard, TCP/IP. So let's talk about some terms that are really important. Okay, a packet. So I'll give you a scenario. If I'm sitting at my computer and I want to go to Amazon.com, first of all, my computer is assigned an IP address, Internet Protocol address, okay? And if I type in Amazon.com in the Google search bar, my request is going to be broken up into packets. Packets are the smallest element of data that's sent over the internet. So each packet is going to contain my originating IP address and then the sequence number from the packet so they can be reassembled at the other end, and the designated receiving address. So again, the IP address is the specific address of any computer, and the IP address is numeric. And I don't know about you, but I have a difficult time remembering numbers, and it's obviously much easier to remember words like Amazon.com. So every website out there has got an IP address, and we don't have to type in the actual numeric IP address. We just have to type in the name, and there's a domain name server out there that translates the numbers, the name into numbers. So here are a few more terms I want you to know. A hub. I want you to think of a hub as just like the center of a bunch of computers connected to each other. Central connection for all of a network. So it basically sends packets to everything in that internet. A bridge is a device, an actual physical device that creates a network from multiple communication networks. So it filters packets. That's really primarily what the bridge does. And then there are switches. Switches are also physical devices, and their purpose is to allow different devices on a network to talk to each other. and it filters those packets based on their destination. Okay, that's what switches do. And routers we're probably all familiar with. We have routers in our home, and a router is essentially a hopping device. If I'm sitting at my computer and I want to go to Amazon.com, that request is broken up into packets, and it hops through the internet using routers. It doesn't go straight to Amazon.com. The shortest path is determined, and those packets hop from router to router until they end up at that destination, which is in this case Amazon.com. Okay, I had planned to do an in-class exercise in which I had an individual that was going to be the sender of the request to go to Amazon and break up packets, and the packets were going to hop to another person who is router number 1 and another person that's router number 2. So anyway, obviously we're not able to do that since we're doing that, learning this chapter in a video. So let's go back to internet terms again. Remember, we have an IP address. It is a number. It is like a telephone number. Okay, think of it as a telephone number or the physical address to my house. Most people don't have landlines anymore, but let's just consider it a landline phone number, right? A landline phone number. So the current situation is what's called IPv4, and this is the number of addresses that are available, which is a problem because we're running out of addresses. So we're quickly trying to move to IPv6, which is going to give us many, many more addresses that are available. All right, so what is a domain name? Again, as I mentioned earlier, it is so much easier to remember names like Amazon.com, or in this case Google, than it is to remember Google's real name, which is 74.125 blah blah blah. Okay? A domain name system or server is like a phone book. It takes that domain name and it translates it to the numeric IP address, so we don't have to remember that. Now, packet switching is another term that I want you to know. And remember, packets are the smallest amount of information that is sent over the internet when you hit enter. So again, your internet request is divided into packets and sequentially numbered, and your originating IP address, the IP address of your computer, is attached to it. And those packets get sent to a router, and the router determines what the fastest path is, and it hops to the next router and hops to the next router, and so on, until it reaches its destination. So I want you to know what a protocol is. A protocol is like a language, okay? It's just a common set of rules. If everybody in the world spoke English, wouldn't it be an easier place to live because we all would understand one common language? So this is how data travels over the internet. And I'll just go through this one more time. So here we have you sitting at your computer and you want to go to Amazon.com. So TCP protocol breaks your request into packets. And remember, those packets have your specific computer's IP address, and then the packet information, and then the sequence number of the packets. And so the packets travel from router to router, and they hop over the internet according to, as it says here, the IP protocol. And then when it gets to the other end, the recipient, and I've been using Amazon.com as the example, the packets are reassembled because we have the sequence numbers, and they know where to send the answer back to because all the packets contain your originating IP address, which remember is like a phone number. Okay, so back in the day, this is when I was when I was learning the internet, right? It began with government, right? It began with the military, and then academic institutions picked it up so that they could share research, right? And then email came to be. And wasn't that a wonderful way to communicate? We didn't have to use fax machines, telephones, and so on. We could send requests and information over the internet via email. And then came the World Wide Web. So let me stop right there and say this. The World Wide Web and the internet are not the same thing. They are not synonymous. The World Wide Web uses HTTP, which is sort of a language that allows us to view internet resources. Okay, so this guy, Tim Berners-Lee, invented hypertext, and then Mosaic came along and figured out a way to use this hypertext to display pages. And then Netscape Navigator came along as the really first commercial web browser. But remember, the internet and the World Wide Web are not the same thing. The internet also uses email. And email is not the World Wide Web, is it? No. So the World Wide Web and the internet are not synonymous. Okay, so then what happens? So now all these businesses think that they need to have a website, right? And this is what we called the dot-com bubble, right? And that happened in the early 90s. So all these businesses thought that they needed a website. And again, here in our slides, it says that in 91, the NSF, National Science Foundation, relinquished control of the internet, and so it was available for commercial use. So boom, everybody wanted an internet page, web page, right? But what happened was the backbone of the businesses behind those internet websites was not done very well. Okay, that those folks need to really focus on the business itself and the business model, and instead of focusing on developing a website as fast as they could. So then we have the dot-com bust, and as that shows here, that Amazon and eBay survived. Okay, so let's talk about Web 2.0. Web 1.0 really is web pages, not interactive as it says here. It's basically like a library, right? It's like you would go to web pages that just displayed information, like Wikipedia, okay? Web 2.0 is came along later, and that allowed users to actually interact with the internet and become themselves part of the internet. And that's when Facebook and other social media inventions came along. And then we are now moving into Web 3.0, which is the semantic web. So again, what is the internet versus the World Wide Web? Remember, the internet is an intercommunication of different networks. Our university has got its own internal network. Then let's say a business down the street, a restaurant, they've got their own internal network. And the internet allows those two separate internal networks to communicate with each other. So that's the internet. It's connecting. It's a network of networks. That's the easiest way to put it. And again, internet and www are not the same. The other parts of the internet are email, FTP, which stands for File Transfer Protocol, and there's other things. So again, World Wide Web is just a service, and it's just one part of the internet. All right, so how did this all come to be? Well, you guys don't remember, but way back in the beginning of the internet, we had what's called dial-up. And the users, every user that wanted access to the internet had to have a dial-up modem, a modem. And you would get on the internet, and this is what made AOL famous, is you would log on to AOL because you had a subscription to their service, and you would hear boo, 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 and that was using their that was allowing you to get on the internet, but it was traveling over standard communication lines that were used for telephones, right? That had been in existence for a long, long time. And those communication lines were really, really not designed to move big mountains of data and traffic, right? They were designed to move audio. So a modem, in fact, the purpose of a modem was to turn your digital information on your computer into sound, so it could travel over this telephone network. And then at the other end, it had to be broken back into zeros and ones so that the receiving computer could understand it. So now let's talk about broadband, okay? That's when we had cable services and other services that allowed us to have much, much better access to the internet, much better access. And it's just phenomenal how fast we can move traffic on the internet, how we can stream videos, and so on. It says here my internet speed is about 75 megabytes per second upload and download. That's pretty good. There are some companies that I think Bright House, which has another name, I can't remember what it is off the top of my head, but they have 100 as their standard, 100 upload, 100 download now. So the more that broadband grew, the more that the internet grew, and the faster that the internet became, and the more capacity that the internet had. It was just a more wonderful thing. So now what do we have? Along comes wireless. So in the back of your computer, there used to be a NIC card, and it looked like a telephone plug, right? And then you would connect that to your router in your house, and that's how you would connect to get out to the internet. So that was extremely inconvenient, right? If you had different computers around your house, you'd have wires going everywhere to connect to the router. So wireless came along, okay? So wireless is wonderful. Almost all computers now come with wireless, right? And some of them still have that LAN connection in the back, but so many places that we visit now, our university, places like Starbucks, you go to the doctor, they have free internet, right? Free wireless internet. And again, no cords. If you're using a smartphone and you connect wirelessly, you're not using data on your telephone plan. You know, my plan is with Verizon. But here's the problem. These free internet connections that, like, for example, Starbucks has, they are open to everyone. They're open to everyone. People don't need a password to get on them. They just go to Starbucks and boom, they're connected. So what does that mean? Well, it means that the bad guys can easily be connected too. And if the bad guys can get in, then there is the potential for them to get into your computer, which is connected to that wireless network. So here we go. Wi-Fi computers, laptop, tablets, smartphones. Then comes along Bluetooth. Okay, and we're all familiar with Bluetooth. In my car is Bluetooth enabled, and my phone is Bluetooth enabled. So I can stream the music that's saved on my phone through the speakers in my car through Bluetooth. And so the Bluetooth in my car has to handshake with the Bluetooth on my cell phone. So I want you to know what VoIP stands for. That is Voice over IP. And this is really cool, okay? So in the bad old days, everybody had to have a telephone in their house, right? They had to have a telephone. And you had a physical line that actually connected into the wall somewhere. And outside of your house was a connection to the wires overhead, right? So Voice over IP is a distinctly different service that enables you to make and receive telephone calls without having to have a physical connection like current landlines do. Okay, so let's talk about different companies and how their networks work. Okay, an intranet is a local area network in a small area, right? And this is the best way to differentiate between a local area network and a wide area network. A local area network is a network in which all the communication lines are owned by that institution, like USF St. Pete. If we are just communicating with each other in different buildings and we don't have to lease lines from a third party to communicate, we are operating solely on a local area network. Now, on the other hand, if we need to go across the street, we can't really stretch cables across the street, can we? Nope. So we're going to have to subscribe and pay for that communication system, and then it becomes essentially a wide area network. So extranet, intranet is a local area network, and the extranet is allows partners into your network. An extranet allows like vendors that supply you raw materials. They are able to tap into your network directly. So that makes it so much easier for businesses to be productive. SharePoint is owned by Microsoft, and it is a set of programs that allow internet users to communicate with each other. And we talked a little bit about Google and Google Drives, and SharePoint is very similar to that. In this case, multiple users can edit a Word document and so on, except that SharePoint is a lot more robust. It has a lot more functionality. SharePoint's owned by Microsoft. So we had already talked earlier about cloud computing, but visually we often represent the internet as a cloud because it's out there somewhere and we really don't care where it physically is, right? It's in the cloud, it's in the internet. So this picture is interesting. We have an in-house server on the left, and on the right we have a variety of servers that are in the cloud, and those are called a cloud farm. Cloud farm, so know that for the test. Okay, this is interesting. Metcalfe's law. How useful is an internet program? Really, when it comes right down to it, how useful is it? So in this example, it says that Facebook, for example, is only as useful as the number of users that it has that actually use it. And recently, the statistics are showing that people are backing away from using Facebook. I myself don't get on Facebook nearly as much as I used to. There's too many ads. It's just cumbersome. It's just a pain. It's just a pain. I like Instagram, and again, Metcalfe's law applies to it. Its value lies in the number of users that use it. So, in summary, we talked about how the internet began, what is a network, and the internet is really, it's just a connection of a network of networks, right? And it's all based on the Internet Protocol IP and TCP/IP, right? Each computer that connects to the internet has its own unique IP address, right? And uh, um, websites that you go to have their own unique IP addresses. And as humans, it's difficult for us to remember numbers, obviously. It's a lot easier for us to remember names like Amazon.com. So we have domain name systems or servers that transfer that Amazon.com that you typed in into its actual numeric IP address. Okay, then we talked about some other key terms that we needed to know. Remember, in the beginning there was dial-up, AOL, and it used modems. It was really slow and cumbersome. And then along came broadband, that you could buy internet usage from different providers. I used Frontier, and then there are other cable providers and so on. And then we went back to internet use at the corporate level, and some of the different schemes that are available out there. So, this is Chapter 5. I hope you've learned a lot. Study it, review this video several times, and you'll be good to go. Well, remember that I told you that every computer connected to the internet has its own IP address. So I thought you might be interested in finding out how to find out what your IP address is at that time, at that moment. And so we need a command line, okay? So I'm going to click on Start, and in the search bar, I'm going to type in CMD for command line. And this is what it looks like, okay? And we get a blinking cursor here. And this is a command line in which we have to actually type in transactions, right? Names. So the one that you're going to type in is IP config. IP config. And there it is. There is my internet address, IPv4 address, 10.211.55.5. That's it. That's who I am on the internet. So another fun thing you can do is see how I hop through different routers on the internet to get to somewhere, and that's what we're going to do next. That command is called traceroute, T-R-A-C-E-R-T, and we want to trace route to Amazon, AMAZON.com. Okay, enter. Let's see how many hops it takes us. There's one. That's it. That's it. That's as far as we needed to go. And let's see if I can stretch this window out a little bit bigger. Well, I can't do it. So Amazon.com's address is 2 something, maybe it's 205, yeah, 205.251.242.103. So remember that all computers that are communicating over the internet have their own IP address, and when you get on the internet, that IP address is selected for you, okay? So you're not always going to have the same IP address. On the other end, like Amazon.com, they have to have the same IP address all the time. They have to for those domain name servers. So anyway, I thought you might be interested in actually seeing how this works. What is my IP address?